Suppose you have a wire that leads into another thinner wire of the same material that has only a third of the cross-sectional area. If the current is a steady state and the drift speed of the thick wire is 4 times 10 to the negative fifth meters per second, what is the drift speed of the thin wire? Well, we know we can relate the two because the number of electrons per second in is the same as the number of electrons per second out. The number of electrons per second is related to the function density times the area times the drift velocity or drift speed, whichever you want to call it. Because we know we can relate these two, we just plug them in as such. Alright, so these are the same densities, so the densities will cancel, but they're a different cross-sectional area. We know that the area of the thinner wire is 1/3 the area of the thick wire. So plugging that in, we get this. We know that the drift velocity of the thicker wire is 4 times 10 to the negative fifth. So plugging that in, we want to multiply by the inverse of this. It'll cancel with that A. And now we have 3 times 4 times 10 to the negative fifth meters per second. And plug that into a calculator, and we've got our answer. 1.2 times 10 to the negative fourth meters per second. And that's our drift velocity of our thin wire.